everyone, and welcome to our second course in the Professional Certificate Series, Six Sigma and Lean, Quantitative Tools for Quality and Productivity. The second course is Six Sigma, Analyze, Improve, and Control, and we're covering the Analyze, Improve, and Control phases of the DMAIC process improvement methodology used in Six Sigma up to the level of a green belt, based on the American Society for Quality's certified Six Sigma Green Belt body of knowledge. There are 3 courses in this edX Professional Certificate Series. Course 1 is Six Sigma Define and Measure. Course 2, Six Sigma Analyze, Improve, and Control. And Course 3 is Lean Production. Each course has the option to be taken as a verified certificate, and upon completion of all 3 courses with verified certificates, you will receive then the edX Professional Certificate and the Technical University of Munich's Lean Six Sigma Yellow Belt certification. It's mandatory that you pass and achieve a verified certificate in all 3 courses in order to obtain the Professional Certificate and the Yellow Belt. The Yellow Belt will be provided as a separate certificate by the Technical University of Munich Executive Education Center, and it indicates a mastery of Six Sigma and Lean concepts to a Yellow Belt level. So in Course 2, what you'll learn is to analyze data using inferential statistics techniques in order to determine confidence intervals, and to test hypotheses based on sample data. We're also going to review cause and effect techniques for root cause analysis, and we'll learn to perform correlation and regression analyses in order to confirm root causes. We'll also learn to plan and analyze designed experiments and to implement statistical process control using control charts. We'll also review quality methods such as the 8 disciplines, or 8D, and 5 Whys, used in managing process deviations. And finally, we'll follow a full Six Sigma scenario covering all of the DMAIC phases with Master Black Belt Dr. Rainer Hutwelke at the end of the course. The course is organized in a series of video lectures over 8 weeks. There's approximately 60 minutes of videos each week, with practice problems and interactive online exercises to support each module. In this course, we've developed 2 mini case studies for you, and there are still the continuation of our projects throughout the course for applying the statistical tools for the Analyze, Improve, and Control phases. Of course, we also have homework problems every week. These must be completed to pass the course. So you need to check the homework timing, the schedule for the homework submission, which is published in the course timeline, and you need to pass them, achieve a passing score on all of these homeworks in order to pass the course. Now, again, as before, this course covers statistics. Not all of it, but in the second course, a good portion of it. And we're basing this, of course, on what we've already learned from course number 1. But here we're applying those initial fundamentals then into the Analyze and Improve and Control phases. But don't be worried. We will work on this with you. We have, of course, practice problems that are specifically designed for each section and to support you with each homework. And there's a discussion forum where you can ask questions about the practice problems, about not homework problems though, please. That you should mail to the course organizers. But you can use the discussion forums to ask questions, to discuss topics that are related to our course material, and we'll be pinning discussion threads on relevant topics so that people can exchange with each other and share information about the particular topics in this course. We also have interactive exercises. These are developed with the Technical University of Munich IT students. This one is from Sanjay, Srinath, Saad, and Radia. They worked on a DOE, a design of experiments exercise. And the idea with this is that if you need to visualize the statistics, you can do that with these interactive exercises. And we hope that will help you to understand the statistical theory. We also have 2 mini case studies, as I mentioned. These are also developed with the TUM IT students. These are by Abu, Mushfiq, Masuma, and Mahadi. We worked with Mellon Helmets to develop 2 case studies where you can apply Six Sigma statistical tools to production scenarios for root cause analysis and statistical process control. We also continue our projects. The first project, which we started in course 1, Rafik and Diane had developed with the company Hanwag, who make very high quality hiking boots here in southern Germany. And they're going to continue to guide you through the project through the analyze, improve, and control phases. We also have the project that was developed by Simon and Benny with Kopschitz Kerzen, also a firm over 100 years old. Over 200 years old, also now here in southern Bavaria. And this family-owned company has been supporting us to give us an idea of how we can look at candle production and apply the DMAIC cycle. And again, we'll look again at analyze, improve, and control in this course. And finally, our highlight is a complete Six Sigma project, Cookie du Chef. This is developed by Master Black Belt Dr. Rainer Hutwelke, who has over 25 years experience working internationally with big companies on Six Sigma projects. He has developed also an Excel-based tool which supports the entire DMAIC cycle, and you can use this tool to help you structure and work through then your own Six Sigma project. But he will be guiding us through a series of lectures in the end of the course to apply everything that we've learned in course 1 and course 2. Just a couple words on our textbook. This is the textbook this course is based on, with Drs. Krishnamurthy. Professor Krishnamurthy is a professor from Bradley University in Peoria, Illinois. This is an excellent textbook. It's now in its 3rd edition. And some of the corrections from the 2nd edition have come from the students in the MOOC who have found some typos, for example. It's very good. It combines the managerial aspects of quality management with this basic statistics, which is also what we're trying to do in our course. I do think if you're interested, it's available also as an ebook, and it has more than we have in this course. For example, it has sampling techniques for if you're looking at incoming material. It has sections on other types of quality systems. It has also more details on the statistics if you're interested. So if you'd like to learn a little bit more, or you'd like to follow with our textbook, please take this as my recommendation. So, course structure. We're going through from course 1 and course 2 through the DMAIC process improvement cycle: define, measure, analyze, improve, and control. Our first course covered define and measure. So just a recap, we understood the background and meaning of Six Sigma. We understood the role of the DMAIC cycle in Six Sigma and introduced the concept of process yield. We also linked this to the Six Sigma requirements of 3.4 parts per million defective. We learned to identify the voice of the customer and to translate customer expectations into the so-called critical to quality parameters. We then identified the influencing parameters in the process using process mapping, and learned to calculate process yield and process capability for our initial baseline process. We also covered the basics of a measurement system analysis. Now, in this second course, we're going to continue with the stages analyze, improve, and control. And each week, the lectures will cover the statistical methods required to support these processes, with a goal, with the practice problems, with the case studies, with the exercises, and the 2 projects, that you can practice these methods first in this course, and then apply them in a quality improvement project, either in your work or even in your own life. So we hope you enjoy this course, and we look forward to spending the next 8 weeks with you. Thank you.